Hi, my name is Heidi, and this is my 3D model of the respiratory system. And I'll be explaining how the respiratory system works in its homeostasis state, as well as the disease state, which I've chosen to be asthma. This model shows the main parts of the respiratory system and how each part functions. So starting at number 1 is the nose/nasal cavity. This is where the air enters the body. Then the nose warms, filters, and moistens the air before it moves downwards to number 2, which is the pharynx. This is the passage that connects the nose and the mouth down to the larynx, which is number 3, which is also known as the voice box, which creates sounds when we talk, and it also helps the air travel into the lungs. And at number 4 is the trachea. This is the windpipe that carries the air from the throat down into the lungs to then number 5, which is the primary bronchi, which are these two tubes that brings air into each lungs. Then at number 6 is the secondary and tertiary bronchi. These branches help spread air throughout the lungs. Then at number 7 is the bronchi. These are the smaller tubes that control airflow. They can either widen or tighten depending on the body's needs, and they're the main airways that get affected during asthma attacks. And then at number 8 are the terminal bronchi. These are the final tiny passageway before the alveoli. Then at number 9, since alveoli are so small, they are tiny air sacs where the gas exchange happens. Here, oxygen enters the blood and carbon dioxide leaves the blood to be exhaled. Then, at number 10 is the diaphragm. This is the main breathing muscle. When it's pulled downwards, the lungs expand and fill with air. Then when it's pulled upwards, the air is pushed out or exhaled. Then, of course, at number 11 and 12 is my right and left lung. During its healthy state, or its homeostasis state, the respiratory system has the air moving smoothly through these structures. When the diaphragm contracts and moves downwards, this causes the lungs to inflate, and it's pulled through the trachea, the bronchi, the bronchioles, and into the alveoli. When the diaphragm is pushed upwards, the lung deflates, and the air is pushed back out. This shows how breathing works in its homeostasis state. So this is how the breathing would work in a homeostasis state. And this would be our healthy lung, and this red inflamed one is our diseased lung. So during its disease state, which is asthma, it's a chronic inflammatory disease of the airways. And so during an asthma attack, which I've made here the bronchioles constrict, meaning the smooth muscles tighten, and the airway lining becomes inflamed, as you can see here, the red, and swollen. Then excess mucus forms, and it blocks the air passageways. All these changes make it harder for the air to reach the alveoli. So, as I said before, I made 2 different lungs, my healthy homeostasis lung as well as my diseased lung, with the bronchioles that are inflamed and swollen. And I've also made the pom-pom in here yellow and red to show the mucus and the swollen inflamed ones. So as you can see here in the healthy lung, the air flows freely, but with the diseased lung, it's harder for the air to reach the alveolus. The reason I chose the respiratory system in asthma is because asthma is fairly common and affects people's day-to-day lives. And I wanted to know then why, rather than just taking the fact that it makes it harder for people to breathe at times. And I wanted other people to understand why too. The most interesting thing I learned is how these tiny bronchioles are important for the breathing, and how even small triggers like allergens or airborne things like tobacco can cause the bronchioles to swell up and mucus to form inflammation and cause somebody to have an asthma attack, which can be very serious and potentially deadly. If I could do something differently, I wish I could go into more detail in the lungs, as well as maybe make the diaphragm movable. So this was my model on the respiratory system and asthma. Thank you for watching my presentation. I hope you enjoyed it.